Hello students, welcome back to the supplementary video lecture series. Today we are going to discuss about the design of connection. Specifically, this is a one video tutorial sessions. Apart from the regular session, it will be helpful for the practice example of the design of bolted connection. So the data is a member of steel roof truss that is consist of the single angle ISA Indian Standard Angle 100 by 75 by 8 mm connected with a 8 mm thick gusset plate. Member carries the ultimate tensile load of 150 kN. Determine the number of 16 mm diameter 4.6 grade ordinary bolt required for the joint. Assume the ultimate strength of the plate is 410 MPa. Here the single angle is connected with the 8 mm gusset plate and it will be carry the 150 kN tensile load, and we have to design the bolted connection. So based on the basic data, first we will understand that how it is going to connect. So these are typical pictures in which you can imagine the connection. The angle connection is connected with a different gusset plate in all three pictures, and we have to design the bolt as well as the spacing between it, which is called as a pitch and end distance. So first it is a look like this. So there is a one angle section and which is connected with the one gusset plate. So from the cross section it is look like this. In the second pictures you can see. First of all we will start with some basic data. So here the given data is nominal diameter of bolt, that is a 16 mm. As per given in the IS 800, that as whenever it's a diameter of bolt is a there, so whole diameter will be the along with the some clearance. So for 16 mm there will be 2 mm clearance, so diameter of hole is a 18 mm. Then for the 4.6 grade bolt, as we have discussed earlier in the theory, that 4 is indicating the ultimate strength. So ultimate strength of the bolt is a 400 Newton per mm square, while zero point 0.6, which is indicating the yield strength of the bolt. So it is a zero point 0.6 times 400, which is a 240 Newton per mm square. Similarly, ultimate strength of the plate is a 410 Newton per mm square. And as you can see in this figure, there are one gusset plate and one angle section is connected, so there is only one shear plane from where the bolt will try to fail in the shear, and that's why it is a bolts will be in the single shear. The minimum bit distance, that is a 2.5 d. D is a 16, so it is a 40 mm, while minimum end distance, that is a 1.7 times dh, that is a 1.7 times 18, so it will be approximately nearby, you can round up to the 35 mm. So this is a basic data, and based on that we have to design the bolted connection. So I hope that you are having the IS 800 2007 with you. So whenever there is some equations or value, we can see from that, you can refer from that particular close number and page numbers. So let me start with the first step, that here as it is mentioned the close numbers, so you may note down whenever it's required for the future further practice examples, you can refer this close number in page numbers. Next, first we have to find out the shear capacity of the bolt. So shear capacity of the bolt, which is given on the close number 10.3.3, page number 75, IS 800. So FUB by root 3 NN ANB plus NS ASB. Here make sure that FU is a mention, which is a nothing but for the shear, that is the ultimate shear strength of the bolt. So which is a 400. As it is in a single shear, so NN will be 1. We are assuming that it is a threaded bolt, so NN will be 1 and NS will be 0 because shank area will be not there. And A and B, that we have to take as a 0.78 times pi by 4 d square. And it is a, when you put the value right here, ASB shank area is a plane area, so it is a pi by 4 d square, and here A and B, that is a area of the thread, so that will be 22% approximately, it's a decreasing, so it's a 0.78 times pi by 4 d square. So the value is a 36.22. Along with that, there is a design shear capacity is there, so that would be divided by the partially safety factor gamma mb. Gamma mb you can see from the page number 30, table number 5, and that is given as a 1.25. So if you put that, we will get the FDSB, that is equal to design shear bearing design shear capacity of the bolt, that is a 29 kilonewton. Next, we have to find out the bearing capacity. On the same page, on the second column, you can see the nominal bearing capacity equation, which is nothing but 2.5 kb dt fu. Out of that kb, there is a constant which is a depend on the grade as well as the spacing of the bolt, and d, that is the diameter, t, that is the thickness of the plate or section, whichever is a minimum, and fu, that is a ultimate strength of the plate. Make sure here note down that in the shear capacity, wherever it's a fu is a mentioned, that was a nothing but it's a about the bolt. Here it's about the plate. So first we have to find out the kb. So below this equation in the code, you can see that kb value is a given, that kb is a smaller of the four value, which is a e by 3dh. E is a end distance which we have considered 35, we have round up as a 35, and that is a become a 0.65. Second one, p by 3dh minus 0.25, so we will get the 0.5. Third one, FUB by FU, ultimate strength of the bolt by plate, that is a 400 by 410, so 0.97. And fourth, that is a 1. So out of that, whatever is a smaller value that we have to consider as a kb, so it's a 0.5. So kb is a 0.5 from this. If you put down this value in the nominal bearing capacity equation, so we will get that 2.5 kb is a zero point 0.5, d diameter of bolt is a 16, and t thickness of the section or gusset plate. Here both the thickness is given same, that is a 8 mm, so we have to take as a, if it is a different, we have to take the minimum thickness, and fu is a 410. So nominal bearing capacity is a 65.6 kilonewton, and same way like we have done in the shear, we have to divide by the gamma mb, that is a partially safety factor which we can get from the table number 5, page number 30, which is a 1.25, and that will get as a 52.48 kilonewton. Now we have find out the shear and bearing capacity. So generally bolt will be try to fail in a shear only, and that's why we are not finding the tension capacity over here, because anyway tension capacity or tensile strength will be getting the more as compared to the shear and bearing. So we have to find out the bolt value. Bolt value is a nothing but it's the strength of the one bolt or capacity of the one bolt, so which is a nothing but minimum of the design shear and design bearing capacity. So based on our answers, we are getting the 29 kilonewton, which is a design shear capacity is a minimum, which is a bolt value. And based on that, we have to find out the number of bolt, that is total load divided by bolt value. So design load is a given 150 divided by 29, so it is a 5.17. So we have to round up it to the 6 number of bolt. So that we have to show in the form of the detailing over here. So this is a detailing that one in the cross section as well as in the longitudinal section, we can see the design of this connection, that here we can see 16 mm bolt, we can see just as a one line which is connecting ISA 100 by 75 by 8 to the gusset plate of 8 mm thickness, while in this section we can see single line of 6 number of 16 mm bolt, and in between you can mention the spacing of that bolt also, which is a nothing but it's a pitch, which is a 40 mm we have considered. So if you are considering 40 multiplied by 5, so that is a nothing but it's a 200 mm, while there is a two end distance over here, it is a end distance, and here also it is a end distance, so that is a we can say 35 mm both side. So approximately we will consider the overlapping distance, that is overall 300 mm. It is a near to 270, but you can consider as a overall distance as a 300 mm. So this is a detailing of the this practice example. So overall you can see the this is the most simplest type of the bolted connection, and so here we are concluding this video, and hope you will similarly you can do the practice of the some little bit more higher type of the connections, and you may refer it from the any standard reference book. So before concluding, there is a one review question, just think about it and you may give your answer in the comment section. So if the same amount of the load is acting, but in place of the one ISA, if two ISA, two Indian standard angle sections are going to connect back to back on the either side of the gusset plate, so how many number of bolts are required and what is going to change in the design point of view? So just think about this answer, and we will meet for the another video session. I will try to prepare another one for the welded connection. So do the practice, and for any doubt, please contact me personally, or you can comment in the comment section. Thank you so much.